The much more common way that money can grow is compound interest. Compound interest is much, much, much more common than simple interest, and compound interest involves a situation where not only is interest or earnings accrued on the original amount, but on all accrued interest or earnings. So what happens is in the first period, you earn, you have some money in there and you earn some interest on that or earn some returns on that. So now at the end of the first period, beginning of the second period, you've got more money. Well, when you earn your interest or your returns in the second period, it doesn't just earn it on the original amount, but on that accrued interest as well. So let's take a look at an example that highlights that. So today we have $100 and we're going to earn compound interest of 6% per year. So 1 year from today, it's time for the bank to say, okay, how much money is in your account? And they say, well, there was 100 at the beginning of the period, and we pay 6% interest, so we'll give you 6% or $6 in interest. So now after a year, you'd have the original 100 plus the 6, you'd be up to 106. Well, here's where things get interesting, because now we're 2 years from today, and you would have the $106 at the beginning of the period because it includes the original 100 plus the $6 you got in year one, and you earn 6% on that. So in the second year, the bank says, okay, we're going to pay you $6.36. $6 of that's the interest on the original 100, but there's that 36 cents, which is the 6% on the $6 that you accrued last year. So you started with 106. You got 636 at the end of 2 years. In 2 years from today, you have $112.36. How about year three? Year three, you go into the year with $112.36. At the end of the year, the bank says, okay, we're going to pay you 6% on what you had at the beginning of the year, so it's 6% of that. And now the interest for year three is $6.74. It's the original 100 plus the 1236 that you accrued in years 1 and 2 plus 674. So after 3 years, you'd be up to $119.10. So you can see it doesn't just grow by $6 a year, it grows by an increasing amount. 6, then 636, then 674, and it's because every year there's a little bit more interest on interest. And you can see when you compare simple interest to compound interest, simple interest just increases linearly. So if it's 6% at $100, every year it's $6 more. So after 70 years, your $100 just becomes about $500. But with compound interest, the interest on the interest can become incredibly important, such that your original 100 turns into almost $6,000, roughly $6,000 after about 70 years. One property of compound interest that should seem obvious is that the higher the rate, if you put money into an account today, and here we've got the green line represents compound interest of 6%, the red line corresponds to compound interest of 4%. After a certain amount of time, if you go to the bank and say, can I have money on my green account and money on my red account, you're going to get more money out of the green account. You can see the difference isn't really so much initially. After a year, if you put $100 in, you'd have $106 in green and $104 in red. The next year, you get 6% on the original 100 versus 4% on the original 100 in the red account, but you're also going to get 6% on the higher amount of interest, and that effect becomes quite substantial, such that, again, after 70 years, you're at about $6,000 here, and only $1,500 here at 4% versus 6%. Again, we've talked mostly or primarily about compound interest, but that same concept, and we're going to apply it a lot in this course, applies to any compound return. Again, the key is the rates applied to the original amount and all previously earned or accrued interest or earnings. So it's the return on the return, the interest on the interest, that is central to what gets done in finance. Point here is to assume that it's compound. So we talked it's been talked about before that you should not assume it's a simple rate unless you're told explicitly it's a simple rate. That if you're told that a rate is not, if you're not told if it's compound or simple, you assume it's compound. That's the way rates work. So in the course and in life, you want to assume that the rate's compound unless you're explicitly told, hey, this is simple.